I can talk a little. Whoa, I can talk a little bit about why that is later, but yeah, parallelization is one of the main topics of not the next lecture, but the one after it.
Okay, we're at 10 past, so when you get
Yeah.
started.
So okay, we're at 10 past. Hello everyone. Welcome to the second lecture in the PhysCat DeCal. I hope you all have had a good week since we were last here. Just a couple of logistics before we start. The first homework is due next Monday, I believe. Aditya, is that right?
Yeah, that's right.
Yeah. Um, so I would probably get started on that because the sooner you do it, and if you run into problems, the more likely we'll be able to help you in time. Again, but if you run into problems and you can't solve them before the due date, don't worry about it. Well, that's fine. Like the setup part of this is complicated, and if you run into problems, a large part of that is on us.
Yeah, we also recommend starting earlier because our office hours are relatively early in the week. They're Tuesdays 9 to 10 and Aladem echoing.
Yeah, I'm Wednesday. So yeah, Wednesday 7 to 8, the same time as this class. Any other logistics questions before we start? There is no new homework that's coming out this week. The stuff we're covering today is included in the first homework that was already released. The next homework will be released on next Monday. And that will cover some of the stuff I'm going to talk about in the next lecture. So yeah, Aditya will be watching the chat for questions. I will mostly be lecturing today. So yeah, and you can also DM either of us if you have a question that you want to ask kind of in private. Okay, so without further ado. So most Python code is the kind of the underlying so we're just going to start with a review of Python. Just sorry, I forgot to mention that. The underlying computation that happens in most Python code comes from Python's basic operators that can, so that the things that add numbers, multiply numbers, check whether or not numbers are greater than, less than, or equal to each other. Most of the stuff that happens in your Python program is going to be stuff happening in some of these basic operators. So first off, a programming language wouldn't be very useful if you just, added numbers. That's just a calculator. So the first feature that makes Python a language is that you have variables. So we can assign numbers to various variables. So we say a equals 1, b equals 2, c equals 3. And now we have 3 variables, and we can print them out. So we see print a, and we get 1, right? Python has kind of 4 basic operators that syntax you're probably familiar with. So we have, to add things, you do a plus b, pretty straightforward. To subtract things, you do a minus b, use the minus sign. And to multiply things, you use the star instead of a dot like you might use if you were writing stuff on paper. Because there's no real dot on your keyboard. And if you're dividing things, you use the forward slash, not the backslash. Most of you are probably familiar with this. If you, again, interrupt if you have questions, because I'm going to go fairly fast on this because I'm assuming most of you know it. We can also, of course, mix our variables and literal numbers. So we can do print 1 plus 100, or print a plus 100, and we'll get 101. And we can do that pretty freely. So you can use any mix of numbers and variables in your code. And then to handle order of operations. So the order of operations in Python is by default the one you're probably used to. So if we do this, we'll see that we get 201. So if we wanted to change the order of operations, we can just put parentheses like you would do if you were just writing it on paper. Yeah. So the one operator that does not look like what you would expect, you might expect, for example, the caret symbol to be exponentiation. So if you do 1 XOR 1 caret 1, you would expect that to be 1, right? But it's actually not. The caret symbol is a different operation. That's kind of a legacy from C. So in Python, if you want to do a power, you do double star, and it's kind of like, you learn like multiplication is repeated addition, exponentiation is repeated multiplication. So if you have trouble remembering it, just remember it that way. So you can do 3 to the power of 3, and you're going to get 27, right? That's pretty. I think that it's pretty easy to remember once you get used to it. So you can also use these arithmetic operators on weird things that you might not expect. So for example, in Python, Python also, in addition to having numbers, has strings. So if we do string high and we have string by, you can add them together like this. And if you have two things where you think that, like two things in the base Python language where you think you should be able to add them together, you probably can using the plus operator. If you're not sure, you can just check. You can also use the multiplication operator on strings. So you can do high times 10, and it'll print high 10 times. So those operators are kind of, Python operators occur in a lot of different places that you might not expect. So let's see, what else can you do? So you'll notice that everything here we're kind of wishy-washy. We used 10 and divided it by 2, right? And if you've done any programming before, you'll notice that 10 and 2 are both whole numbers, but 10 divided by 3 is a better example. 10 and 3 are both whole numbers, but this is not a whole number. And if you've not done a lot of programming, you might ask, like, why is that distinction relevant? So you notice that 10 divided by 3 is 3 with an infinite number of 3's after it. When we print 10 divided by 3 here, we get 3, and then a lot of 3's, and then a 5. So one thing that you have to remember when you're writing Python code is that numbers that are not whole numbers, so like 10, are inexact. And this is probably kind of a weird concept because numbers that are whole numbers are exact. This is because there's no real way to store 10 over 3 other than writing it as a fraction. And there's a lot of numbers that you can't express that way, like e or pi. So everything is basically an approximation to about 10 to 20 digits, depending on your computer. Those are called floating point numbers. So when we do 10 divided by 3, when we use division, that always returns a floating point number, right? Even if we do something that makes a whole number. So when you divide integers, you get a floating point number. If you add two things, so 10 without the dot is a whole number, it's an integer. When you add two things like 10 plus 10 dot, you'll notice it prints it out with a dot. So when you use integers with floats at the same time, they get promoted to floats. This might seem a little bit weird if you've used Python 2. Python 2 does not work this way. So say you want, if you're used to Python 2, if you divide 10 by 3, it'll just round down. And if you're used to that, you might want to do that sometimes. It can be handy. Python 3 provides a way to do this, to do those kind of integer divisions and get quotients and remainders like you did when you did math in like 4th grade and you were learning how to divide and you didn't. So you would divide like 10 divided by 3 and you say, well, 3 goes into 10 3 times, and then there's a little bit extra. So the way Python does this is you have integer division. So you do 10 /3, and this does integer division, and it will return 3, right? So it divides 10 by 3, and then it rounds down. The other arithmetic operator that's for dealing with like kind of division style things with integers is the modulus operator or the remainder operator, and that's expressed with a % sign. right? So a percent is kind of, you'll notice a percent kind of looks like one number over another number. That might be an easy way to remember this. So 10 mod 3 is going to be 10 divided by 3. What's the remainder? And of course, the remainder is 1, so it will print out a 1, right? So those are the two of the integer division style operators. And so these don't seem that useful initially. Like, why do I care what the integer division of 10 and 3 is if I can find the actual number, or at least a pretty close approximation of it? There is actually a use for this. There's a lot of uses for this, but the one that's fairly easy to see is if I do 1,324 and I want just the first 3 digits, I can divide by 10, and I do integer division, and I get 132. And if I want to know what the last digit is, I can do mod 2, right? And mod 10, and that'll give me the last digit of that number. The other useful thing is it's a very easy way to check if a number is even. So if a number is even, then it's divisible by 2. So the number mod 2 will be 0. And if it's odd, then it's not divisible by 2, and the number mod 2 will be 1. And you might have done something, you've probably done something like this before. So yeah, so those are Python's arithmetic operators. It actually doesn't have that many of them. We have the four like basic addition, multiplication, division, subtraction, and then we have exponentiation, and then integer division, and modulus, and that's it. That's all the arithmetic operators in Python that you have to remember. Python also has a concept called booleans. So these are something you might not be familiar with. So a boolean is just simply a true or false value. So they act a lot like integers. You can assign them to a variable. You can print them out, right? And Python actually only has 3 boolean operations. We can do true. We can do not. So not inverts. So it takes a true and turns it into a false, and false and turns it into a true. So not false would be true. Not true would be false. We have or. So or says if the thing on the left, true, or the thing on the right is true, or both of them is true. This is an inclusive or. A lot of times in English, when we say or, we mean an exclusive or. So if either or both of them is true, then the or expression is true. So true or true would be true. True or false would be true, right? But false or false is false, if I can spell it right. And then we have and, which is if the thing to its left and the thing to its right is true, then it returns true. You'll notice false and false is false. False and true is false. But only true and true is false. Or sorry, only true and true is true. And using these 3 operators, you can express anything in Boolean arithmetic. You can express a NAND. You can express an or you can express an XOR, right? Because you can just chain them together, and you can apply parentheses. So you can do not R and Q, right? And Q. And that's a NAND. Python also has comparison operators. So say you care about is 3 greater than 4? No, it's not. You can do, and it has the 4 you would expect. So we have greater, we have less than. So 3 is less than 4. 3 is also less than or equal to 4, but it is not greater than or equal to 4. But 4 is greater than or equal to 4. And Python also has a equality operator. So we have 4 equals 4. And why did I write double equals? If I write double equals, I get true. If I write single equals, it's going to error. And why does it error? Because it thinks I'm trying to set some variable 4, which is not a valid name for a variable because it starts with a number, to the number 4, which is not allowed. So the expression, it thinks this is an assignment. If I did print r equals 4, then it's just confused. So you'll notice it provides a helpful error. It says, expression cannot contain assignment. Do you mean equals equals? And you'll run into a lot of Python errors. You don't necessarily need to know what all the words mean, but just try to understand the general gist when you run into them. So yeah, those are the 5 comparison operators in Python. And those are how you check, like, if you wanted to iterate over, say you have a database of all the planets in a solar system and how fast they're going and how far away they are from the sun. If you want to check, which ones have enough energy to escape the solar system, you could use a comparison. It's, very clearly very useful. And then the last, so we've covered Booleans, we've covered numbers. The other major type in Python, so Booleans and numbers are both types. They're types of things. The other major type in Python that you're going to run into a lot is lists. So a list is a collection of other types of things. It's a collection of other objects. So, for example, we might make a list. A is equal to 1, 2, 3, 4. So we can print A, right? And it has 1, 2, 3, and 4 in it. You can also add elements to a list that you've made at any time. So we can use the .append function, and we're going to talk about functions in a minute, but we can use, or this is technically a method, but we can use the .append function to append another number to the list. So now we have that, right? We can also combine lists together. So say we can do a.extend and then another list, and you can use the same list. If we do a.extend with A, then we'll get, the list repeated twice. That's how you combine lists. And you can so say, like, having numbers in a list is cool and all, but I want to get those numbers out at some point. You can access those elements by doing, print A of 0. And that will print the 0th element of A, which you can see is 1. And Python lists, their indexes start at 0. It's a 0 index language. You've probably heard that term before. So if you do print A of 0, you get 1. Print A of 1, you'll get 2. And print A of 4, and you'll get 100, right? You can also set elements this way. So you can do A of 3, which will be this 4 right here. And you can set it equal to 102. And you'll get 100. You've got 100 there. Something interesting about Python lists is that, unlike lists in a lot of other languages, you can mix types. So we showed the string type earlier, right? It basically just contains a number. So we can mix types. We can put a high in here. And this you'll have 1, 2, 3, which are all numbers, and then you'll have high. And this is actually something that you shouldn't be doing most of the time, because when you do this and you pass this list to a function that is, you try to use this list as if it's all numbers, then you run into these errors. So just try to avoid that type of thing. And you can also do horrible things, like you can say A of 4 is equal to A, and that's just not something that you want to do. Basically, we're saying that the 4th element of A is A itself, and you might think that this would crash the computer. Fortunately, the way Python lists work, which we will talk about a little bit today and more next week, makes it so this actually does work, and you can, we can access the 4th element, and then we can access the first element of the 4th element. So we're going into the list, and then that list points back to the list itself, and then we access the first, not the 0, the first element. So we get 2, right? If you do this, if you put a list inside of itself, we're going to fail you, because It's bad. We're not going to fail you. That was a bad joke. But yeah. So you have lists, you have numbers, and you have strings, and you have booleans, right? And that's great. Now you have a really good calculator. You can do, 1 plus 2 to the power of 3 minus 5, right? And you can just write all of that at once. You can say variables. This makes a great calculator. You don't need your TI anymore unless you're graphing something, and you actually won't need it by the end of this lecture to graph things. What it doesn't make is a programming language. We want to give our computers a little bit of intelligence. We want them to be able to think a little bit, not too much. We don't want them to take over the world, but we do want them to be able to make basic decisions on their own. So Python has a couple of things for flow control. So flow control basically controls, we have these basic operations. Now we are going to run them in a particular order and sometimes rerun them. And that's what flow control is. Flow control controls how our program flows. So the most basic type of flow control is actually, I don't know why I have this here. This should go. Okay. I'm gonna jump around here. But the most basic type of flow control is an if statement. So if we have if, 3 is less than 4, which it is, we're gonna print high. Right? And the if just takes a Boolean, right? So if 3 is less than 4, print high. Cool. Now 4 is not less than 4, so it's not going to print high, right? And that's the simplest type of flow control. We also have else. So if 4 is less than 4, then do this thing. If this thing, if this condition failed, if we got false here, instead go do this other thing. So if 4 is not less than 4, print high from else, right? So it's going to print high from else. And if we change this back so this condition passes, we get high. And of course, you can use variables in these conditions. They can occur in any way you want. Something that's interesting and something that you shouldn't do, but might be useful if you run into a bug, is that actually a lot of Python objects can be interpreted automatically as a true thing or a false thing. So for example, for numbers, Python says that any number that's not 0 counts as true. So if I do if 3, that doesn't seem like it should work because 3 is not true, it's not false, but it does work and it prints high. If I do if 0, it will count that as a false value. And there's a lot of things that count as true and a lot of things that count as false. So for example, an empty list will count as false. A list containing one element counts as true, or any other number of elements. Basically, if something is empty, like if, for example, if you have like an empty string or something, that's false, and everything else is true. There's also a none type, which is a type that doesn't contain anything, that's also false. For the most part, this is not something that you should do because it makes your code harder to read, especially for people who are inexperienced, and you can create a lot of strange bugs that are very hard to reproduce this way. But it is something that you might run into if you accidentally do something like this, where you mess up and you don't have a comparison. So the other control flow statement that lets you conditionally execute code is else if, or in Python we call it elif, which I'm not a huge fan of, but that's what this one is called. So else if you can put a different statement here. So if 8 is less than 9, we can add a separate statement, and it will execute whatever is in this block. So like a block of code in Python is specified by it being indented from the previous line. So I can have, more than one statement in here. High from elif, high from elif again. And because 3 is not greater than 4, it doesn't run this. And then it goes down to elif and it checks this condition and it says, oh, 8 is less than 9. So I'm going to run these. And then it's done because we've executed this elif, so it doesn't go to the else. If we change this to, is 9 less than 9, then it'll go to the else. And if we keep this, so this condition is true, but we make this condition also true, then we end up back here and it doesn't run the elif or the else. You've probably seen this before. Python also has two other common types of flow control. Those are loops. So it has a for loop and a while loop. A for loop, so a for loop so say we have some list A, which has 1, 3. A for loop, so we do for I in A. That means take for every element in A, assign it to the variable I, and run the code in this block once for that element. And A can be anything that seems like it should go there. It can be anything that has a set of things inside of it, and a set of things that you might want to run over. So for I in A, print I, where A is this list, it'll print 1, 2, and then 3. We could change this, for I, if we can change A, we add high, it'll do that, right? It'll go through and it will print each element in that list. Of course, you're not going to want to create a list that can, so a really common operation you might want to do is, run over all the numbers from 1 to 100, for example, and perform some operation for each one, right? You could write out a literal list in your code containing all the numbers from 1 through 100. This is usually not what you want to do. Python provides a simple function for this. It provides the range function. So for I in range 10, we'll go through every number from 0 through 9. So it will print out 10 numbers from 0 through 9. For I in range 1, 10, we'll go from every number from 1 to 9. So why is it going from 1 to 9? This is a 10. The right-hand side bound of the right-hand side bound of the range function is an exclusive bound, and it's an exclusive bound because say you want to iterate over all the elements in a list, so the list A, and you want to access all of them, the Python provides a length function, len, that will take a list and return its length. And the length for this is 1, 2, 3, 4, 5, right? But the indexes, we have the 0th index, the first index, the third index, sorry, the 0th index, the first index, second index, third index, fourth index. So the highest index is the fourth index. So if I did for I in, so we print A of I, right? That works. If we were to change this to include that number 5, so a theoretical fifth index, we're going to get an error. We're going to print 1, 2, 3, 4, 5, and then we're going to try to access an element of the list that is not there. The list index is out of the range. So that's why it's kind of has that funny bound. The other thing that the range function has, which is used quite often, is you can specify a step size. So if we set the step size to 2, then we'll do every other element. So we'll do the first element, sorry, we'll do the 0th element, and then the second element, and then the 4th element, right? So we'll skip over the 2 and the 4. Those are the two. So if you ever see like another number here, that just tells it to skip some numbers. So the other type of loop that Python has is a while loop. So if you have, so for example, if you have I is equal to 0, and then we do while I, we can have like for while I is less than 5, we're going to set I equal to I plus 1. So this will run the block of code in here until the condition that it evaluates up at the top is not true. So if, oh wait, we want to print I. So we'll print I, right? It'll run through it, print 1, 2, 3, 4, 5, and then it'll hit 5 and say, okay, 5 is not less than 5, so it ends. That's the other flow control. And if you want an infinite loop, so for example, like a control loop for some robot you're making, you can do while true, and this will run forever, and it prints a lot of numbers, and then I have to stop it with this. Please stop. Okay, cool. Yeah. So where are we? Did I? Yeah. So we have if statements. We did those. So now that you have these loops, these conditionals, and then these operations, you can, in theory, given enough time and storage space, compute any. So you can solve any problem that any computer anywhere can solve, and that's kind of, so what does that mean? This is something called Turing completeness. Sorry, I gotta get my notes up real quick. Give me one moment. Okay, yeah. So now that you have loops, conditionals, and operators, you can execute any algorithm that exists in that any computer in the world can execute. And this makes Python Turing complete. And it's called Turing complete because this is this was kind of, so Turing wrote a paper called Computer Machinery and Intelligence, and it sketched out this very simple computer that can solve any problem that you can solve with like pencil and paper. And that's called a Turing machine. And it's a very simple computer. You can look it up. It looks weird by our modern standards because he's thinking in terms of paper tape storage and mechanical systems, but the same model still works. And so, for example, say we wanted to print out every so say we wanted to print out every digit of a number I. So I is equal to 100. Or actually, that's not a very interesting number. Print out all the digits of 4096. So we want to print out all the digits in reverse order. With what we've already done, we can actually do that. So what we're going to do is say we're going to have this condition while I is greater than 0. Now, why do we have that condition? Well, because through each iteration through this loop, we're going to print I mod 10. So I mod 10 is the last digit of the number. And then you're going to divide, we're going to set I equal to I integer divided by 10, and that'll cut off the last digit. And this will print every digit, right? So it'll print 6904. And that's just an example of an algorithm that you can implement on this machine because, and if you give anyone a specification for any problem, they can implement using what we just learned, you can implement a program in Python to actually do that. But there's so everything from here is basically just making your life easier. But there's one thing that really makes your program a lot simpler, and those are functions. So functions are basically, it's a lot like a function in math. We have some input to the function, right? So some arguments, say f of x. The function does some magic thing inside of it. So say it multiplies it by the slope and then adds the y-intercept if you're doing, f of x equals mx plus b. And then it outputs some value. So it'll output the y value of, some graph, right? And functions in Python are basically the same thing. For the most part, you can think of them as taking inputs and producing outputs that you can use in your program later. So the format for functions in Python is very simple. If you want to define a function, you do def, you add, and you can take two arguments, a and b, and then you just have a block of code. So you have c is equal to a plus b, and then you're going to return A plus B, or sorry, we're going to return C. So now I can use this a bunch of times over and over again. So I can do add 1 and 2, add 2 and 3, right? And you can use all the things you just learned inside these functions. So this lets you write code without repeating yourself a lot. You don't have to copy and paste stuff. And this is generally, if you find yourself copying and pasting any part of your code, write a function that performs the operation in that bit you just copied and pasted, and then call that function. And you'll make your life a lot easier. That's always a good thing to do. Python, what you should also do is, if you're writing a function and it's in a code base that someone else might have to come back to, or even you might have to come back to later on in life, you're going to want to put a little comment to describe what it does. So Python has a way of doing that. It's called a docstring. It's called a docstring. So if you put 3 quotes, you'll make a multi-line comment. And in this, you could put a description. So adds 2 numbers. And then you're going to have, this function will have parameters. So you have parameters A, comma, B, and you're going to describe what those do. Those are 2 numbers you want to add. And when you do your projects at the end of the semester, we're going to ask you for every major function in your project that might want to be, someone else might want to use, you should put a docstring. So, and then you're going to, you want to document what it takes, what it does, and what it returns. So it returns A plus B. And so now we've defined this function, right? And we've added this docstring. Now we can use a very handy function in Python, which is help. So if we do help add, it will magically describe what, it will magically go and pick out our function signature. So add A, B, how you call it. And it will show our, it will show the docstring that we just wrote. And this doesn't seem too handy for functions that you wrote, but if you're dealing with functions that other people wrote in libraries, which we're going to talk about in a minute, you're going to want, this function can be handy to just query the documentation. And then if you don't find what you want, you should go to the library's webpage, and usually there'll be documentation there. So we can also, of course, assign things to return values of functions. So we can say C equals add A, comma, B. Right, and that works. Oh, wow. Add 1 and 3, right? And that works. And we, of course, we can use all the same things we used before. So if we wanted to turn our code up here into a function, say we wanted to make a function reversed digits that takes a number n and returns a list of those digits in reverse. So say takes a number and returns reversed list of its digits, right? We would do this. So we'd say, we'd create an empty list, D, right? And then we do while n is not equal to 0, just like before. And instead of printing, we're going to append it to the list. So we're going to do D, we're going to add this number to the list. So we're going to do D.append to add an element to the end of the list, n mod 10, so the last digit. And then we're going to do n is equal to n over divided by 10. So to remove the last digit. And then when we're done with this loop, we're going to return D. And we can use this function over and over again instead of copying and pasting what we wrote up here. So we can do reverse digits 1, 2, 3, 1, 2, 3, 4. 4, 5, 6, 7.
We've got 10 minutes left. Maybe you want to skip ahead to the libraries part, or you're there already anyway?
Yeah,
because that is kind of.
I'm going to show off Python tutor real quick.
Oh yeah.
I think that's more important. So one of the things you might ask is, when I pass an argument to a function, how does that argument go into the function? So, for example, if we do something like this, right? It, take some number x, and we say x is equal to x times 2, if, and then return that. If we have a variable a is equal to 2, and we call changer on 2, is it going to change what a is? And the answer is, for numbers, it won't. So if we print a afterwards, we'll see that we, return. So if we see that, we see that a is still the original 2. And the same thing's true for, wait, that was a bad demo. Okay, yeah, you see the point. We see the same thing is true for example for floats or for strings, right? The original value is unchanged. This isn't true for everything though. So if we talk about, for example, if we make this a list changer, and instead of changing, instead of multiplying it by 2, we set the 0th element of some list equal to hello from inside list changer.
I think you dropped an equals.
Oh, yes, you're right. And we set a to some list. Then if we call it, you'll see that the original list, after calling list changer, gets mutated, right? So the hello from inside list changer gets copied over to the new list. A good way to debug these is with a tool called Python tutor, which can, when you're not sure what Python code is going to do, you can copy it into Python tutor and step through how it works. So if we put list changer in Python tutor, right, and we copy our code into here, and we click visualize execution. So we're going to step through our code. So first, we have a variable that Python, in the global frame. So those are the things that the Python interpreter knows about, called list changer, which is a function. And then we're going to set up a, which is another variable in the global frame, which points to 1, 2, 3, 4, which is a list that contains each thing. And then we're going to go to print list changer, which calls list changer up here. So we're going to go inside this function, and inside this function it has the variable x, which points to the same thing in here, which points to the same list as the global frame points to. And we're going to change it, and we're going to return it, we're going to print it, and then we're going to print it again. So you'll notice that when we were here, the list changer's variable had a pointer, which we're going to talk about in the next lecture, to the same list. So if we change this to, actually, we don't have time for this, but if you were to change this to, what we had before, it would just copy that value into the variable inside changer. Okay. So that's just kind of a gotcha. We're going to talk a little bit more about that in the next lecture. But for now, just kind of accept that when you pass in things like lists or classes, which we're not going to use in this course, but you might run into, those will get mutated when a function changes them inside the function, whereas numbers do not, and things like numbers do not. Yeah, so the formal terms are pass by value and pass by reference. One of the biggest advantages of Python is not all of these little fiddly things you can do, because you could, of course, you can compute anything that you compute with the things that we just learned. But writing any algorithm in just pure Python would take forever. So Python has a really rich collection of libraries which can do a lot of these things for you. They can do a lot of them better, and they can do a lot of them faster. So NumPy is a really good example of this. So for NumPy, we have, if we want to, we could, when we have a library, we want to import it. So we might do import NumPy. What you'll see a lot is when you do import NumPy and you want to access one of NumPy's functions, and a library is basically a collection of functions and values, and basically anything that you can give a name to in a Python program. So if we do import NumPy, we're going to do NumPy dot pi. We'll show pi, right? Writing NumPy out every time is it's a bit of a pain. So we can import NumPy as np to give it a new name, and then we can. So if we wanted to add a list, right, we would have some function add lists, which takes two lists, A and B, and makes another list C, and it goes through all the elements in A, right? And it sets C, A of I plus B of I, and then we return C. And if we run this, we print if we do add right, it'll create a new list.
B is like 3 or something. Just
Yeah.
redefine B.
Yeah. So if we do that, it'll add together the two lists, right? And that took a while. NumPy has an easier way of doing this with NumPy arrays, which are a lot like lists. You can index them the same way. But if we do A is equal to np.array, right, we can just do A plus A. And that's a lot easier. And NumPy has a lot of functions like this. So we can do A times A. NumPy also has common it has like common mathematical functions. So you can do np.sign of A. We'll print the sign of each number. And you can also do things like np.sum A, right, which will add them all together. We're not going to cover all of these, but you can look at NumPy's documentation for these. These are all really handy. A lot of physics code in Python uses a lot of these NumPy things, uses a lot of NumPy's functions like this. And one of the big reasons for that is because NumPy's functions are a lot faster. So for example, if we do C is equal to list range 10,000 and D is equal to list. And then we use NumPy's functions to make NumPy arrays that are C and D. np.arange. So arange creates a range, but in a NumPy array instead of a list. Actually, range doesn't create a list, but we can talk about that later. NumPy.arange, 10,000, and same thing here.
You're also going to do, or you may have done, some examples of speeding things up with NumPy on the homework.
Yeah, but if we time these, sorry, I know we're We are using NumPy, not MATLAB, Wendy. Sorry for going slightly over time. If we time both of these, and time it is a magical Jupyter Notebook command to time how long something takes, we'll see, oh shit.
Can you just do that in a different cell so you don't rerun everything?
Smart.
So over there in the first line, you see 1.22 milliseconds per loop when we just do it with lists. Now watch as we do it with arrays.
Yeah, so when we did it with NumPy arrays, we got like a 400 times speed up. You notice it took 3.41 microseconds as opposed to 1.22 milliseconds to add these two lists. And there's a lot of the reasons for this, which we're going to talk about later. But what you should take away from this is a lot of times if you're dealing with large numbers in like large arrays of numbers in Python, like you're doing matrix math or vector arithmetic, you should use NumPy, and NumPy supports all of those. So we are out of time. I'm sorry, I expected this to go faster. I wanted to introduce some more fun things, but we're not gonna have a chance for that. So y'all are free to go if you want, but I am here to answer questions if anyone has questions.
Yeah, we had a few in the chat as we went through.
Okay.
If you have questions that you didn't get to ask, wait, Alec, can you mute yourself real quick? I keep echoing. It's really weird. Yeah. If you had questions that you didn't get to ask or that you're not exactly sure about, we have office hours. Mine are tomorrow 9 to 10, Alec's are Wednesday 7 to 8, and we are pretty responsive on the Discord as well. So please ask everything you want to know. If there is something that, you know, is in the sort of standard bank of Python things that we might assume and forget that not everyone knows, ask us about it and we can help out. And if there are questions that come up on the homework, which is a little bit more advanced than this, but not much, ask us about that too. Okay, thanks for coming, everyone. We'll see you in office hours and lecture next week.
All right. Thank you, everyone. Was there anything in the chat that didn't really get addressed?
No, I think I got everything.
Okay.
God, this echo's so weird.
If you come to my